All right, so we had a very good week this week. I think the biggest thing that we did this week was put all the elevator stages together, which ran pretty smooth on Saturday at Lamar. We posted videos on it on Instagram, YouTube, and in Slack. So yeah, I was very happy with that. I think the next really big step, is going to be to figure out how we're going to make this elevator square. So something that we discussed a lot was how we feel about using the end caps versus the gussets. Um, with the end caps, they are a great tool, but they are in extremely high demand and are currently sold out. So we won't be getting any more of those. Les did print out some end caps that have threaded inserts in them, so we've been using those in some spots. Um, I think overall, in terms of keeping things square, I do like them. We put them all over the elevator. So instead of gussets to join all the stages together to make the squares or to make the boxes, the we did in fact use the printed end caps. So we are still kind of debating whether we want to keep going with that with the 3D printed ones, or we should switch to gussets. um, Really, the main concern is just strength and how consistent and reliable they are. We also did put them in a drivetrain, so that's something we have to consider. I think in terms of how good they are at keeping things square, I think I do like the end caps better. There's a lot less things that can go wrong in terms of how square can we make it, as compared to gussets where I've had struggles in the past making things aligned correctly and at the right angle. So we'll get into that. More recap of yesterday. We did finally machine parts off of the CNC, which is good. We machined these aluminum plates. I think we have one or two right now, out of 1/8 aluminum. And then yesterday I had a closer look at these gussets and adjusted the belly pan. If we're not Now that we know we have a CNC going, it's much more important that I get this belly pan extremely final, so that after we cut it on the CNC, we don't need to make any surprise holes. So yeah, I have a cutout for the motor, cutout for the Spark Maxes. We also put our whole drivetrain together. We did incorporate these. These are new for this week. We added the Spark Max brackets here, and yeah, I think that's most of what we did yesterday. I think another big debate that we're having is whether we want to do the live axle or the dead axle here for the tube, because we realized that the way that we adapted this plate, we can really work with both of them, whether it be a live axle or a dead axle. So that's something we've been considering. Um, yeah, we also have been. I did just moments ago add this turnbuckle. I realize it's extremely big. I don't think we need it to be, because I tried to pick one that has at least 100 pounds of um, weight that it could lift. But now that I think about it, I don't, because I that was when I made that decision. I initially thought we were going to climb with the elevator, but since we don't really need to do that anymore, I think 100 pounds is a little bit overkill. So we can, of course, well, that's something you have to look at. Get a bit of a smaller turnbuckle for rope tensioning, and then I think that's all the major changes so far. I think we also did put the battery together. I have some issues here, but and when we actually put the battery in real life, it's fine. We found a spot for it. That'll just be something I need to take a closer look at to make sure all my dimensions are right. But we did put the whole battery mount together, and it works pretty well. So, yeah, I think that's all the major updates for the CAD this week.
I would pull the Rev Robotics turnbuckle. I think it's got smaller size.
Is that for the chain?
They have two.
Oh,
They have one that's called like an M4 eye to eye, which I think is what you have in your CAD, but just smaller.
I see.
Yeah, pull that model. It's probably the better size for what you're trying to do.
Because I've been also looking on McMaster here and trying to filter out some of the ones, but it's McMaster is a bit overwhelming sometimes.
Just a lesson for everybody is going to these part websites, especially the robotic part websites, is a good way to learn terminology, read through the guides. So anybody who feels like they're getting started in this and want to learn more, I recommend going through these websites. Some of them are pretty small, and you won't have much time or much effort to go into them. Um, Places like Rev Robotics and Andy Mark, those are getting pretty big. But McMaster is like the dictionary. It has everything, and it's fine to just spend some time on McMaster because it's not really robot specific. I mean, a lot of parts can be used on a robot, but there's just a lot of mechanical parts on McMaster, and just spending time sorting through McMaster is a good way to learn. Now, Cedric, I don't want you to do that right now. You got too many things to do, but everybody else is more than welcome to start browsing these websites and learning more about how all these things work. So.
Yeah, like Cedric, can you look at the belly pan
Yes, I'm gonna pull that up.
where you had the shape for the what's it called, like the mounts?
Yeah. So
Don't do that. Here we go. We're gonna talk about this. There we go. Let's see. Once they load, or do you just boxes?
I can just isolate it.
Oh, there we go. No, it's fine.
That's fine.
So look, you don't need that tab
This
that
one?
goes in. Yeah, you also don't need the thing on the other side. They're not doing anything. So you want structure from a belly pan, and after that point, remember how we talked about triangles?
Yeah.
Now you want the triangle to be as big as possible because everything before and everything after the triangle of the gusset doesn't really do much. Same idea here. After that point, it's not really doing much.
So you're saying just cut it off until like here and just make that?
Yeah, and especially when we're trying to make it, we're not going to be like the pieces, the actual like mounting pieces themselves are not that accurately made. They're pretty good, but not like insane good enough that they can pull stuff off like this.
Yeah.
You're gonna hit it, right? So don't do that. Same thing with the tab beside it. You actually want that clearance. You actually want the space there beside it, so you can like move wires and stuff.
Yeah.
And put your hand there, essentially.
Mm-hmm.
Yeah.
Think about where these the inner holes are for the
I don't even use bar there. What? I don't even use bar there. What do you
those
mean?
are going to add a lot of strength.
What talk to the bank?
These ones?
The button goes in the screen.
Okay.
There's a lot of them.
So I just need to cut the belly pan off like right here on all the sides, or on all the necessary sides.
What are you doing?
Pretty much.
Like your
Bars.
and then like 7,
Okay.
8, 9, it's like so 8.
I also need to cut out for the elevator motor because the way the Neo is, I mean, we talked about it already, but the way the Neo is, it's
for both.
Yeah.
Plan
For-
for 2 possible motors.
Oh yeah, that's true. Okay, I can add that later.
And do we have is our CNC big enough to do all of this at once? Or are we gonna split it?
It should be. I mean, we haven't really measured it, but if we eyeball it, it looks pretty good. We can always obviously we're gonna have to measure and have a close look at it, but if you just have like an actual measurement on it, but if you look at it, it looks like it'll fit.
Oh, on the edges too, you want to add a little bit of tolerance.
Okay.
Yeah, because that looks like it's right up against it, and you don't want that. And never have stuff right up against each other. Like, literally, just the heating, depending on like the temperature, it might actually just change it.
Yeah.
So. And something else to think about when you're doing the end caps, especially the metal ones, is every single screw you put into an end cap needs to be Loctited.
But if we use the 3D printed ones, you can't do that.
Yeah, so that you shouldn't use 3D printed ones. listen. after when we build it for real, you shouldn't use three different ones, right? But what I mean is like when you use the end caps every screw you put into one should be Loctited.
Yeah, that makes
Yeah.
sense.
So that's something else to consider if we're actually gonna be able to make sure every single screw. That's a lot of. I mean, it's like 11, right? Like you said.
It's like it depends on how they mount, but anywhere from
Okay.
like
Yeah.
6 to 11.
It might be interesting to do a mix too. Like I know some parts you need like both sides,
Yeah,
like cut off, right? So you might want to like do end caps there, but a different part you want to like do gussets. You have to be careful because the when you do gussets, once you riveted them, once you pull the rivet, they're just on there, right? With an end cap, you can take it off.
yeah. My concern also with end caps is weight. Um, I mean, this robot is designed to be pretty light. The rest towns had it at like 70 pounds minus the battery and minus the bumpers. But with the decrease in the weight limit this year, I feel like adding that many end caps and then accompanying screws with those end caps, if we do that times like 8 to 10 or 11 or 12, that weight's going to add up. And I don't know if I like that or not. Especially on the elevator, like that thing's going to get pretty high. We tested it on we put the elevator next to a tape measure and we did get to L4. We don't have the official reef, but we did get to L4. But like if we have that many end caps going that high, that's going to be pretty heavy. And even the carriage already is heavier than I thought it would be. So that was also my concern with the end caps is weight.
Yeah, I'm not concerned about the weight. It's really just a stability thing. And what we'll do is we'll just save spaces for gussets. So if we feel like we are done and ready to finalize things, then we can start riveting gussets, and that's
Yeah.
fine. So let's just make sure we save a space for it. So if we need to start changing out to gussets, we're ready to go.
Yep. I mean, that's kind of what I've been doing in CAD. If we look at the elevator bracing here, I made two versions, one with one that's assembled out of gussets, and then one with max tube end caps. Carl suggested that I turn this yellow tube 90 degrees. It's just mated, but turn the yellow tube 90 degrees. But I haven't figured out a way to do that and make it work. Yeah, it's good. I mean, I think eventually I'll think of something, but yeah, he said to turn this one 90 degrees so it's stronger. Um, but yeah, here's the gusseted version, and then if you want to look at the end caps. Nope.
Yeah, I don't think I care that much about the in-cab version, Cedric. I mean,
Yeah.
the
Okay.
gusseted version is going to take up more space, and as long as we reserve that space and we start making gussets, we'll get to that point.
Yeah.
The end caps are like a way for we get to quickly assemble things. And obviously, if we had metal ones, then we'd feel more confident about them. But right now, we're just doing end caps with a lot of 3D printed stuff,
Mm-hmm.
and that's fine for quick assembly. But when we start getting into final robot, it's kind of like switching to lock nuts. I mean, now we're making it a lot more rigid and sturdy that won't vibrate itself loose.
Yeah.
So we'll get there eventually, but let's just keep room for it, and we can even 3D print some gussets as a reminder that we need to have them in this spot when we actually CNC them, or I don't know which ones we're going to use, but yeah, we have a handful of metal gussets that might fit as well. Yeah, the lift is good. Let's think about the motor system. So I can't find that plate for the motor down here.
This one.
Yeah, so we might be making something temporary,
Can we?
or mean,
Are
I'll
they
definitely
are
order
they
it.
in stock?
Yeah, I
Yeah.
think it's in stock. I'll order it, but I just don't know how soon we'll get it. So,
Yeah.
um, but it's fine. It's really not much there. Even if we use the other one temporarily, it should still give us an idea
Yeah.
of how everything's going to fit. Um, these pulleys are from McMaster. Is that correct?
These are Andy Mark pulleys. So these are, if you go to Andy Mark, they're the climber in a box winch pulley.
Oh, I
There's
see.
they have the wider version and the like the 2 inch and then a 1 inch version. And so
What's
I
the
was
one
thinking,
on the lift though? Those aren't any mark, are they?
oh, these pulleys, oh yeah, these are McMaster.
Okay, so I need to order those too.
Yeah, I'll put those on the spreadsheet later.
Yeah, whatever McMaster you have on your list, let's get a McMaster order in if we need different bolts and stuff. That's a good place to get bolts, especially unique bolts. Bolt Depot is probably the cheaper place, but McMaster, if we have any weird long bolts, sometimes they can be better or easily found on McMaster.
Yep.
So the big thing we have to do is we have to drill those motor holes or decide if we're going to use max tube instead.
Yeah. Instead of the grid, because right now we have we had like switched between these like 3 times already. Whether we're gonna do max tube grid pattern or max pattern. Um, we initially did grid pattern because we didn't know what the elevator was gonna be yet, and then when we decided we wanted to copy Rev style with the 2 sprockets on the drive rail or on the drive bracing, we switched to max pattern, and then now that we flipped this up, we were like, it may just be better to do grid pattern, and so I don't know. We're still, yeah. I mean, personally, I still think the grid pattern would be better, especially because now if we're gonna make this elevator gusset, I mean, we're gonna probably have to. Carl suggested that we use every hole that we can to put this together, and I think if you do max pattern, it's gonna be a lot less. It's gonna be a lot less holes, and the max pattern is also a lot more annoying to cut because the pattern offset has to be all correct, and I just don't want that to lead to issues when we actually build it.
Why didn't you want this gusset to go out a little bit towards the motor?
What do you mean? Like to this side?
Yeah, just like a little bit.
Well, I just haven't had time to like think about it. That is something Carl suggested was can't you just he suggested just integrate this whole assembly onto the gusset itself. And I haven't like had time. He suggested yesterday, and I haven't had time to like really look at it closely and see how that would look like. But yeah, I'm working on something in my head on how I can make that work.
Okay. Yeah, it's not like critical. I feel like we can get everything together and start testing stuff. Um, so let's think about what's like critical. What's on your mind that like we really need to build and construct.
I mean, I had hopes that we were gonna drive the drivetrain this Saturday or this past yesterday. Um, but I think I don't know. Honestly, I don't know. Uh, yeah, I guess it's just get the drivetrain going and make sure everything is fine and it's set up so that once we have other subsystems that we can put on top of it, it'll be much easier to integrate them instead of having to change a lot of stuff.
I think you should be looking at the big picture, and we should be throwing almost everything we can into the physical robot to make sure it all fits, and then we don't have
Mhm.
to move anything. So that's like the climber stuff. Even if we're just making boxes and we're putting the support bars for it, I want to see it all because you and I were going through it on Saturday, and there's a couple things that we could immediately tell needed to change, right?
Yeah,
So
we changed some stuff already.
yeah, so let's look at the big model of everything in the CAD. Um, Things like the battery switch. We could throw something on there really quick, and where the battery switch um, gets mounted, let's just throw it all on there. And that's how we're going to test the robot too. If we get the battery, battery mount is done, battery connector is done, finish the battery switch, put the power distribution board on, we should be able to drive the robot once we have those pieces in place.
Mhm.
And then we just try to add. We want to have almost everything on this robot, just so we can make sure it all fits. That's the important
Yeah.
part. Do you have the full model so we can look at it?
Yes. Here you go.
So even if we just put some temporary support bars for the funnels, maybe they're
Mhm.
like extra long or however we want to put them in, we just have them up there because the funnel algae system obviously is going to get tight,
Yeah.
especially with the battery right there. Yeah, but I think we need to add those bars in.
Like these blue tubes down here, I would assume. Oh, this one got mated off, but it's supposed to be in the center.
That's for the climber, right?
Yeah, this is the motor. The climber motor is gonna be mounted to that.
Yeah, putting that in there and just even if it's just really rough, like clamped in, and then putting like a Rio and a PDB board underneath it, making sure that we feel comfortable getting our hands in there and working on stuff.
Yeah.
Because we might want to flip some orientations around if we don't feel comfortable. I think that power switch needs to go on the outside, right?
Yeah, probably. I thought I had it on the outside. I don't know. Yeah, but yeah, it's gonna probably have to be on this side of this face of the tube, which is fine.
I feel like it should be even more out. It should be like in the gap between the outer like the actual drive rail and the supports.
So in this general area.
Yeah, like I need to understand like when the robot like a battery leaks or something, a volunteer needs to be able to click the button, like even without even sticking their hand anywhere near anything that's moving.
Hmm.
We could attach it to the battery if we wanted to.
Yeah, that battery mount seems like a good place to put it.
I saw they were working on something to try to put the Anderson, the switch, and the battery thing just all in one, right?
Yeah, what happens if we take that outer battery plate you have highlighted and we just
Hmm.
make a new plate that fits the power switch and swap that out there, and then the power switch will just mount right off that plate. I don't think it's going to interfere with anything.
Can the battery cable like bend like that though? Because that sounds like a sharp bend to make. Is it bendable in that sort of? Because if it,
It goes to the connector. It goes to the
well,
connector and
yeah,
then it goes to the thing, right?
yeah. But what I'm saying is it gonna be able to make the bend between like the connector and the connector and the switch, or and then has one of them has to go to the PDH. So
Well, the switch is already on the inside battery plate, is where we have it. So it should loop to the switch pretty easily. And then I
okay.
think your point about getting to the PDB, we would probably have to. This is, I guess, another advantage of using Max Tube is we could, or we got to make a hole that brings the
Hmm.
battery wire into the PDB, or bring it over the frame or something. However we want to do it.
Yep.
I guess it's not that different. We probably could just bring it right over the frame and won't be an
Yeah.
And also on the battery mount itself, on the battery plate itself, this was back when we had max pattern on the drivetrain, so that's why the holes on the bottom are like kind of weirdly spaced because of how our max pattern is set up. Do you think those four holes are going to be enough, or should I make another version where it's a couple more holes, like 6 or 8 holes on the bottom?
issue. Yeah,
You're
if
muted,
we're
by
gonna
the way.
make this battery switch thing, I'm fine with making the outer
Andy,
plate.
you're muted.
Oh, sorry. If we make the outer battery plate bigger, I'm fine with making a little bit of redesign to add more holes so we can mount to the frame.
Okay.
Yeah, I don't think that hurts. I mean, a lot of these things, even if you have some excess holes that we never end up using, I'd rather just have them there instead of just not have holes.
Yeah.
The
Okay.
only one I think you really need to remake is probably this outside plate.
Then make it like bigger.
Yeah, um, extend it out, and then we'll put the battery kind of in front of, or the switch in front of the motor side, or in front of the winch. Does that make
Okay.
sense?
Yeah, yeah. So would that means would that mean there would be connection points for the battery for this plate onto the outside rail?
There already are, yeah.
Okay.
Like if you look how they mounted it,
They have like the spacers
they had
and the
two connection points to the outside rail and two connection points to the inside rail.
yeah.
So we could add a few more connection points to make it a little more stable, so you're not putting as much force on those bolts. Um, but yeah, it's a pretty solid mount. I mean, better than what we had last year. So. But this is, Carl was like insisting we need to beef up our batteries
Yeah.
because we were putting too much force on the belly pan with the battery.
Yeah.
So. And then I think you need to dig deeper into the algae system. Like we need to see where the motor is going to go. Also, kind of plan out if we're going to do a motor on the motor or pneumatics. I think you design a motor system, see how it all looks, and then if we have time, we can run the numbers on a pneumatic system as well. But
Okay.
I'd rather start with the motor design first that we could quickly put together and see where that goes.
Okay.
I think for the funnel, we're kind of running out of Neos and 40 amps, so maybe we'll use like what's that motor, a bag motor that we have on the Versa that we did a prototype on, because the funnel doesn't have to be accurate. We can literally just run the motor until it goes up to a point and then stop. It can be a brush motor. The algae arm, I think, needs to be a little more precision though, because we want it to go up a certain amount, we want it to go down a certain amount. So having a brushless Neo, I think, still makes sense there.
I mean, worst comes to worst, could we just make that like a passive deployment, like how the restaurants had it, is where it's literally just a rope, or I guess two ropes on each side.
We can, but I'd rather. It's kind of like putting stuff together in a jigsaw puzzle. I want to just put all the pieces in there. So if we say to ourselves, "Yep, we like the motor better," then we have the space. We've planned it out. But if we don't need a motor, then yeah, we'll just test it without one, and we drop the motor. But at least we have a space for it.
Okay.
Just plan for like the absolute worst case scenario. Like pretend everything that you want to be passive suddenly needs like a motor on it.
Yeah, yeah.
Yeah. It's better to like have the space reserved and not use it than not have the space reserved
And
and just turn it off. Then have to just have your subsystem not work.
Yeah. Either way, we got to bulk out this interaction between the way the algae arm gets deployed and in the funnel system. So, and if you're happy with those plates, those are things that we probably should laser cut soon, so we could quickly test this out on a ball to make sure it's working correctly.
Yeah.
How about the climber? How does that fit into this?
We haven't looked into it's gonna be the everybot climber, and so what I have right now is just these three tubes here. it's definitely something I need to look at a little bit more just to make sure and confirm that it all fits. Especially since we have a cage now, we can actually like test it and make sure that it's right. But yeah,
Yeah, and these are easy tubes that we could put together. So for
yeah.
reference, these are straight dimensions from everybot. Those 3 tubes.
Yes, these are all everybot dimensions, which aren't really that difficult. I think they're pretty simple to cut.
Yeah, so we didn't like just make these up out of thin air. I think these are specific to how it fits in the cage.
Yeah,
But just putting the rest of the everybot pieces in there to make sure it all fits is good. And we should get it. We ordered it, so we can test that all out. Even if it's really, even if we don't lift the robot, I'm okay with doing a test where we grapple onto the cage, and then we by hand just move the cage into the robot to see what it looks like.
yeah,
Because the cage kind of will be coming down on the battery a little bit.
yeah.
Which, yeah.
Wait, which direction is it coming from? The battery side?
What'd you say?
How does that? Sorry, I'm confused on like which direction the cage will be coming in from.
Oh, so it's gonna come in from this left side, and it's gonna pull to the middle of the robot.
The battery side?
Yeah. So it's gonna the way that the cage moves is the same way as the Ressam's climb. It's just the way that it attaches and how it latches onto the cage is different, but it's the same sort of. It's sort of the same principle.
Okay.
Just pull it to the middle of
I
the.
think a CAD shot of the cage coming into the robot will help us quickly see some potential issues.
Yeah.
So
Yeah, because right now it looks like the funnel is just very much in the way, you know. So
Yeah.
put it at least a block or something that shows like how the whole system, where the whole system's going to be.
I think the fixed funnel section this is overkill. I think that could be. I think once you put the cage in there, you'll see some places that you probably need to reduce the fixed funnel. We should probably just make that a lot smaller, and it really doesn't need to be very much, because there won't be a lot of places for the funnel to go at that point, or the coral pieces to go.
Yeah.
I definitely don't think you need all the extrusion for that. You know, you can probably replace that with something more, something that's smaller, because that's a lot for something that's even not even take.
For sure.
Yeah, that's a lot. That's a lot, especially for something that's not like taking direct force. So.
But it's getting there, Cedric. I think you're doing a great job.
So what would I if I were to change these 2x1s? What would I make?